Welcome back to Data Architecture Day, sponsored by the Triangle Area SQL Server Users Group. So, hopefully you've had a chance to grab lunch or dinner or, whatever time it is wherever you are right now. Kick up your feet and get ready for a session on hybrid data warehousing with Johan Ludwig Brattås. So here we go.
Hey everyone, welcome to this session. I'll try to get things set up and started. Let's see now. Sorry for a bit strange here, but I'm on a cabin up in the mountains, so things are lagging a bit, but I think I should be ready to share my screen now. And hopefully we can see that.
Yes, coming in just fine.
Perfect. So, my name is Johan Ludwig. I work for Capgemini Norway as managing consultant, focusing on solution architecture for in the data space. For those of you on Twitter, you can look me up for intolerance. It's not because I'm an intolerant bastard, but because I have some food intolerances. So yeah, sorry about that. I co-organize SQLServer Oslo, frequent volunteer in general for PASS, and I teach CDX how to bake when I'm not spending time in cabin or working. So today we are talking about hybrid data warehousing, looking at the data landscape as it is, definition of hybrid, why on-premises and why cloud, looking and thinking about what you have to do to move to the cloud, going to look at components to consider in hybrid setup, and then look at some different scenarios or architecture solutions that can be of interest when you're looking at these things. So I guess most of you have seen this hype curve before. This one's pretty old. It's from 2013. Cloud computing got into the throes of disillusionment. On-premises is, of course, way over in the plateau of productivity. 5 years later, cloud computing is also passed into the realm of what we do every day, at least for some of us. I know there's a lot of on-premises still going on, but cloud computing is here, and it's definitely something you should look closer at. So I see my slide on definition is passed. I'll make sure to add that so you can when I upload it to Kevin. But in my definition of hybrid data warehousing, we are looking at either when you are moving parts of your solution. So either you move to cloud to get your big data processing done, or you start moving components of your on-premises data warehouse to the cloud. So, for instance, moving all your reporting into the cloud, that might also be considered a hybrid data warehousing solution. So, why should we stay on premises? Well, you've already got that established data warehouse, or most people have. And of course, you don't need to spend billions of dollars on making a data warehouse and then throwing it out the window because something new and fancy comes along. Even though I guess most of us geeks truly would love that, most enterprises and CFOs would refuse. So, second point is, if you are dealing with sensitive data, cloud might not be the thing that you're looking for, or you might be afraid to put data in because you don't trust cloud computing yet. Which leads me to the next point. Your enterprise or your company might not be ready to move into the cloud yet. There are still so many things stuck in solutions that are not portable. And of course, it might be a little bit of everything. And in these days, with the GDPR and other privacy regulations, like the California Consumer Privacy Act and so on, there are a lot of other different things to consider as well that you might not have to really think about on premise, but that will scream at you when you're moving into the cloud. Of course, if you're dealing with GDPR data and you haven't actually started considering what the impact is on your on-premise warehouse, you have a problem anyways. Okay, why should you move to the cloud? Well, if you are struggling to handle the amount of data on premise, for instance, you're having one single SQL DB that handles the operational data store. It has the EDW, and you even have your cubes on it. I've been at clients like that, and pretty large ones as well. Or you might have new kinds of data coming in that again is too large for your on-premises data warehouse to handle. You might need more flexibility, so there are times in the month or times in the year where there is reporting needs that are outscale what you have on premise, but you don't really need that big hardware lying around the rest of the year. You might not have the data warehouse yet, and in that case, why should you even consider establishing one locally when you can move to the cloud and have flexibility of the cloud? And you can have a lack of own infrastructure, own IT department and IT resources. And in these scenarios, why should you start buying hardware to virtualize what you need on premise and then have to apply or employ people to maintain it for you, patch it, and so on? Why not just buy that as a service from a cloud provider? And of course, dealing with economy of scale like the big cloud providers do, things can get cheaper, though they are, of course, earning a massive amount of money on this. There's no real incentive for them to save you money, to put it that way. The most important part here is you can get access and flexibility, and that way save money. Just moving to the cloud to save money is a wrong approach. So, are you cloud ready? If you haven't already started a journey to the cloud, sorry to sound a bit consultantish, but that's the way I am. You should do a cloud readiness survey, because no matter what you think you've investigated already, if you haven't really tested all your sources and tested all your services, you might be in for a nasty surprise. Then there is also things like your personnel, your governance frameworks, and so on. If those aren't prepared to meet the cloud's way of working, you will struggle later on. Then you need to think about your ETL process. How established is it? How stuck are you in using an ETL tool that is maybe not very cloud friendly? What options do you have for loading times and so on? Do you have any regulatory data or compliancy data that you need to think about how you move into a cloud setting? What kind of infrastructure do you have? Are you running everything on VMs? Do you use dedicated hardware? If you're using dedicated hardware, it might be even worse to move into the cloud, because you have no control over your disks and so on. So it's you're losing performance. However, if you're running on VMs virtualized in your on-premises service center, it might be a bit easier. Do you have any budget constraints? Do you think, or is your company struggling to invest in a new hardware or invest in services? Might be better to move out of a capex kind of budget into a more opex, so spend and pay as you go instead of investing upfront. Do you have any new demands for big data analytics? New data sources coming in, or somebody running around saying, I've heard about data science, let's do something. When that hits the CXO level, you can have some fun discussions. Do you have any data strategy for your self-service analytics? That might also impact how you are thinking about clouds. So components we'll be looking through are divided into several parts. You have the Azure Stack, which is we'll go through that later on. Then following for you, those of you who have been working in the cloud a bit, that kind of talk about ingestion points. We'll be looking at integration services, Azure Data Factory, Azure Event Hub. You can also say Service Bus or similar. Then you have a transformation layer with Databricks, Data Lake Analytics, Azure Stream Analytics. Serving storage, which will be Synapse / SQL Data Warehouse and SQLServer. Then we'll be talking about Polybase, and then we'll be talking about the serving layer as well, so Analysis Services and Power BI. Oh, if you haven't heard about Azure Stack already, what is it? Well, Azure Stack is Azure in your own data center. You go ahead into one of the approved partners of Microsoft to get yourself a stack of computers that is then preloaded with all the different Azure services, and you get that trucked into your data center and spin it up, and you have subsets of Azure lying around. So is it really all that good? Not really. Thing is, what's cool about it is it's prepackaged and tuned hardware, so more like an appliance, and the software that you need for Azure Stack. That is definitely hybrid. So it's, as I said, it's a full Azure experience with some very strong limitations on it. As it's more geared towards applications and VMs, web apps. There are some data solutions coming in, but it's nowhere near close to a data warehousing solution. However, Azure Stack might be a very good option if you are doing things on an oil platform, or you're doing things on a huge ship and you need to have at least some compute power closer to you rather than having it in the cloud. But for a data warehousing solution in itself, it's nowhere near ready. So, SQL Server Integration Services, SSIS. You can have it on premises or you can have it in the clouds. I guess most of you have been working with SSIS before. It's a great tool for doing both pull and push integration. It's both an orchestrator and a transformer. It has been around since 2005, and then you had GTS before that. So it's well known. Lots of people are using it. It's even easy now to start using things like BIML and automating, making things quicker to develop. But it's still traditional ETL, so it's extract, transform, and then load, so transform in memory. Then you have Azure Data Factory. And Azure Data Factory was launched quite early in 2014 or 2015, something. But let's not talk about version 1. Let's just focus on version 2. And Azure Data Factory is a pure cloud-based solution. It is an orchestrator. It has some simple tasks that it can run, like both pulling and pushing data. For processing power, it usually demands something like either SQL database or Databricks or Data Lake Analytics or another processing power to actually transform the data. It also comes with its own SSIS runtime, which is then a separate instance of Azure Data Factory, and you can load all your SSIS packages into Data Factory and schedule them to run. Pretty straightforward, changing connection strings and so on, and then they should be running just fine. You need to have an Azure SQL DB to install your SSIS DB on for this to work though. It's also quite pricey. If you forget to turn it off, you might be in for a nasty surprise when the budgeting comes around. Azure Event Hub / Azure Service Bus / Azure IoT event endpoint in the cloud. It is based on Service Bus, and it's very easy to configure it as a cloud endpoint for AMQP or HTTPS. It has up to 7-day data retention. If you're going for Service Bus, it actually has up to 14, but that's a bit. Service Bus might not be the best solution for you unless you do a lot of other kinds of events as well. Just for data warehousing, Azure Event Hub is good. It also runs on or integrates with Kafka if you prefer to use Kafka instead of the Event Hub. Azure Event Hub can write events directly to Blob. As for security, it has only shared access key. Compute power is where you will want to go when you deal with Databricks. And Databricks has been a hot topic for the last few years, ever since Microsoft ditched Data Lake Analytics in 2017, I think, and pushed everyone over to Databricks. It is Spark as a service or Spark containers as a service. And as a matter of fact, Databricks is not Azure or Microsoft company. It's its own independent company, but Microsoft liked it enough that they're pushing it as a first-line service. It comes along with its own workspace where you can run notebooks. Lots of functionality. It's really good for all kinds of ETL work. It's also very good for massive parallel processing. You'd set up different clusters of Spark machines that you can choose between. These clusters can even they spin up when you want them to. So they are just. It takes about 5 minutes. I can't really say that they're ready, hot and ready. But it takes 5 minutes to spin up, and then you can auto shut them down after they've been inactive from everything between 10 minutes and upwards to 2 hours, for instance. But it's really strong work. You can use Python or Scala, as those are the two main preferred languages. Though you can also run R, Spark SQL, or Markdown if you want. But most people run either Python or Scala. Which actually brings me back to a slide I haven't updated properly. Data Factory version 2 also now comes with what they call mapping data flows. And mapping data flows is actually what you see is what you get, drag and drop interface to create Databricks ETL. So it's kind of an SSIS approach to working with Databricks. And under the hood, it creates or generates Scala code that then is deployed to the Databricks clusters that you specify in your job. So for those who are not familiar with Python or Scala, you can do a lot of things in Data Factory mapping data flows. I mentioned that Data Lake Analytics have been dropped. It was Microsoft's own big data solution using a language they call USQL, a mashup between .NET and SQL. It was scalable, very flexible and extensible. I've had customers who've been using it and loved it. But then Microsoft dropped it. It's not deprecated yet. It's still alive, but Microsoft are pushing all customers who are running Data Lake Analytics to migrate their code over to Databricks instead. Stream Analytics is another processing engine. It's a service for event and unbounded data, so IoT or real-time, other kinds of real-time data. It can enrich event data with lookups from blobs or even from SQL tables. So if you have some sensors running around with the sending of readings with strange sensor names, you can actually then create a lookup table and enrich that, or you can otherwise also enrich the data. It's also extendable with Azure machine learning models or JavaScript UDFs, so you can even further scale it up. And it's a subset of SQL, so it's a very easy query language to start off with. And it has advanced windowing functionality because it's again it's an analytics tool to work on real-time data, and you want to window in your real times and do aggregations and calculations in Windows. One thing to mention about Stream Analytics as well, it is not the cheapest thing to spin up, but if you are planning on doing more than just loading data into a table, it's actually a very good solution because it can both stream data live into a Power BI dashboard. It can simultaneously store data into a blob store and then aggregate and run analytics on the data stream and then store it, for instance, either in a Power BI dashboard or into a SQL database or something else. Then you have Synapse Analytics. And Synapse Analytics is service formerly known as SQL Data Warehouse. It's a better name because SQL Data Warehouse might lead people to think it's a data warehousing solution. So again, it's not your regular OLAP cube. It's not. It's basically SQL. Yeah. It's scalable parallel processing of tabular or SQL data. It comes with two different versions, which are either compute heavy or the older and cheaper version. I'm not even sure if the cheaper version will exist in Norway now. They've spun up the generation 2, but they haven't bothered about generation 1. Azure Synapse Analytics is more than just SQL Data Warehouse. Parts of what we know that will come there because the main things in SQL or the old SQL Data Warehouse is alive and in production everywhere, and that has come with some nice new features like query caching and materialized views and so on. But it's only part of the package. SQL Data Warehouse, Synapse Analytics is also Spark containers that you then can run big data queries on. It is also a workbook like in a workspace as you have in Databricks, where you can do Python, Scala, SQL, combine data from Data Lake store and from SQL Data Warehouse, and build pipelines on them, transform them, and you can even build Power BI reports in this workspace. But it's still in private preview. You might see some announcements in build for public preview, but yeah, I don't have a specific date for when it comes into public preview yet. For SQL Data Warehouse part, which is now, I think they've even called them SQL pools within Synapse Analytics, there are some limitations. For one, it is a massive parallel SQL server, so it has a controller node, and then it has the compute and store nodes underneath. I think the minimum is 3, and each of those 3 are then parallelized in 6 separate servers. So you need to think about how you distribute your data across the nodes, across the compute nodes, for dimension data and the fact data. It is definitely geared against or towards star schema kind of operations. However, it's also per default column store technology. I know a lot of people are very fond of column store, and they do talk about how fast it is. Personally, I'm a bit mixed. It might be fast, but it might also be terribly slow. And it depends on the kind of queries you're running. If you have an analysis services cube or model, or you have a Power BI report doing a select star from a table, column store index doesn't even tickle. But if you're doing aggregational queries, so max, min, average, and so on, it does perform really fast. Then you have services like Snowflake, and Synapse Analytics is Microsoft's attempt of being a Snowflake killer. Snowflake is purebred massive parallel processing data warehousing solution in the cloud. It's also third party, but you can get it on Azure as a service there. Then we have SQLServer, which most of us or all of us love. You have in the cloud, you have Azure SQL DB in various sizes and colors, from the old DTU versions with standard premium, basic standard premium levels, so B1 to B4, S1 to S10, premium P1 to P8 or something. And now you also have general functionality. You have business critical and you have hyperscale. And hyperscales, as the name says, scales up to several hundred terabytes, and has quite a nice IOPS. Same with business critical, has a very nice IOPS on it, but the older ones, like standard version, had like, I think business critical is 5,000 IOPS to start off with, whereas standard edition of DTUs was like 500 IOPS. So yeah, definitely something to look into. They've also now launched serverless Azure SQL, which again means that you can run smaller loads cheaply, and then it can shut down or pause as it turns idle. Which is also something I forgot to mention about SQL Data Warehouse or SQL pools in Synapse, is that that is also a feature that can be paused. Then you have Azure on-premises SQL Server, which has been around for quite a while, to put it mildly. Lots of different versions running around. I know there are still 2008 R2s in production, probably also SQL Server 2000, which was my first proper production version back when. But yeah, however, what really is good about SQL Server in a hybrid scenario or in solutions where you really can't move anything into the cloud, the latest version, SQL Server 2019 with big data clusters, is a great solution for those of you who want to do big data computing and the modern data platform, but you're not allowed to go into the cloud. So if you haven't checked out that yet, do check it out. And there's even a nice book written by Ben Weissman that you can check out for that. So the main technology to look for when we are dealing with a hybrid solution where your data warehouse is on premise and big data compute is in the cloud is Polybase. Polybase was first introduced in SQL Server 2016. It lets your SQL Server connect to Hadoop and to external files. It's supported both on SQL Server on-premise and in Azure Synapse or SQL pools. It supports push-down compute on Hadoop, which means that if you have a connected Hadoop cluster, you can query in a SQL, for instance, in Management Studio, and then Management Studio sends that the SQL query translated into Hive and pushes it down to Hadoop, who then does backproduce jobs on its clusters and returns result to you in your Management Studio window as it looks like pure SQL. It supports both blob store and data lake store as well, so all HDFS formats. It was never really a huge hit in version 1 for the simple reason that not a lot of people have Hadoop clusters lying around. However, the ability to connect SQL Server 2016 and 2017 to an Azure Blob Store means that you could easily implement a nice hybrid scenario to import data into your SQL Server on-premise after having it calculated and massaged in a big data solution in the cloud. Coming in from SQL Server 2019, you also have Polybase version 2, which lets on-premises SQL Server connect to Azure Data Lake Store version 2. And it can also use Polybase for external data in SQL Server, Oracle, Teradata, Spark, and MongoDB. Mind you, though, it's when I first saw this, I thought, oh, finally a way to get rid of linked servers. But there are some limitations. It is multi-threaded, but it is not proper secure. So it might be a good solution in some scenarios, and in others you might continue working with your SQL or your linked servers. But again, because you now have the ability to work both with Blob Store and Data Lake Store, which was previously only supported on Synapse, it lets you connect to Azure in a new way to get loaded data in. SQL Server 2019 also comes with Polybase scale-out groups, so it lets you handle a larger load of data connections as long as you have the hardware or the VMs for it. I was supposed to show you a demo now, but my demo's environment, of course, as always in the presentations, it failed. So I'll just briefly explain how you will query with Polybase. You are going to use something called an external table. It will show up in Management Studio as an external table, but as long as you query against it, of course, there will be a lag from when you are kicking off the query until the result comes back, because there is a distance between the data and your own server. But it will be returned as a normal, regular query result. And then you can use that as a staging table and import data into your own server, which again means that it's very easy to select into a staging table from external table, and you have a nice little staging environment to then continue working on that data. We've been working with a large Norwegian bank that implemented this solution because they didn't have the power to process their web bank application logs locally. So they set up a data analytics solution in Azure to chew through those web logs and then import the finished result back into the data warehouse via Polybase afterwards. When it comes to Synapse Analytics or SQL pools or SQL Data Warehouse or whatever you want to call it, Polybase is really the best way to import data or do ETL at all, for the simple reason that since you have a small controller node, whenever you try to do SSIS or data factory connection to it, you are talking to the controller node, and you can't really insert data in a proper way. You will get a bottleneck there. So instead, you are doing Polybase directly from one of the compute nodes, and you do there's a command called create table as select, which only works on SQL pools, where you then import data as a bulk into one of the nodes, and then you will do transformation and distribution of the data within the back end of the cluster instead. So Azure Analysis Services, which is SSAS tabular mode in the clouds. We might want to look at multidimensional. However, there is no multidimensional support in Azure at the moment. They've been talking about it for several years. There is nothing yet coming in. First, they said it was coming into Azure Analysis Services, then they said Power BI. I wouldn't hold my breath for this. If you need to move those, I would look at just doing a pure VM instead. Analysis Services connects directly to Azure SQL Server as long as the connections are open. If you are connecting it to data on premises, you need an enterprise data gateway or Azure Runtime or whatever they've named it recently. I haven't checked for a while. They do change names all the time. However, one thing I forgot, it also connects to Data Lake store. So you can import data directly from Azure Analysis Services from Data Lake and process it and deliver it directly. It does need Azure Active Directory. So when you are, even though you can just deploy your models that you have on premise into an Azure Analysis Services, if you haven't enabled roles that are Azure AD enabled, you will get errors. So instead of having regular usernames, you need to use emails and so on. Pricing is a bit steep. On the other hand, you can pause them, and as a single source of truth or a single repository or single semantic layer for your reporting, it might be a very good feature. But still, the price tag is something that has paused companies and made them consider other options instead. Then you have Power BI Premium, which is, among other things, it's SSRS in the clouds. With Premium, you can do paginated reports, which again is importing your reporting services reports directly into Power BI. Works like a charm. It's, of course, also Power BI. It is an SSAS competitor in that since Power BI, as you know, it's running the same Vertipack engine as Analysis Services Tabular mode. You can pretty much do the same things there as you can in Analysis Services. What you couldn't do before was have large data sets lying around, or you couldn't have share the models between several reports. But that has changed now, so that you can both have up to 400 gigabytes large data sets, still in preview, I think, but it's coming. And you have shared data sets that you can connect to different reports to, which again means that whether SSIS will be alive or an Azure Analysis Services will be alive in 3 years' time, or if it's part of Power BI, I'm not sure. Personally, I hope they actually have 2 separate services instead of bundling everything together, but that's me. Cool things about Power BI Premium as well, it has proper data lineage, which no other part of Microsoft Stack has. It has impact analysis. Again, means you can actually, when you change a column in your shared data set, you can actually see which reports will be affected by that and which ones actually might fail. Of course, Power BI Premium isn't free, so it's there's a price tag connected to that as well. So let's look at some different architectural scenarios or solutions that might be applicable when we are working with hybrids. If you are running your traditional SQL Server on-premise, you have SSIS, SQL Server for both ingestion and transformation and serving, so ODS and EDW. And you're using SQL Server Analysis Services for your cubes and your models. And then you can actually move your reporting into Power BI Premium or into Power BI Pro. You can even run, good thing about Power BI is that you have REST APIs, and it's easier to connect and expand on those web services there.
Johan, real quick, could you click the hide link on the screen?
Oh yeah, it's there we go.
Thank you.
Yeah. I put in data catalog in here because that's one thing I really miss in the on-premises world. Azure Data Catalog, as it is right now, it's so-so. It's not great, but it's better than what we have. There's a version 2 coming out, which I haven't really played that much around with yet, but it seems to improve on important things like for Data Catalog then lets you tag all the, or map all the different data sources that you have. It lets you tag columns, let you tag calculations, KPIs, lets you put resource or users that own the data. So it's easier for self-service that way. Version 2 also lets you, from a data catalog entry, lets you actually open the Power BI report that has connected to that catalog entry. It's also possible here to hide data sources from some kind of user, so role-based access. And you can browse sample data and so on. Yeah, there's also, of course, the traditional security to think about, so both transparent encryption and always encrypted. Dynamic data masking isn't really that much of a security feature, but it's nice to have in an ETL setting at least. This is also a solution where you have data coming in from an external blob store and load it directly into the SQL Server using Polybase. So, what another scenario that you can use is still keeping your data services on premise, But then you in the cloud, from either from weblogs, APIs, or delivery of big data sets that are on irregular interval, you can use Databricks to process those big files, while SSIS is still doing the traditional ETL load on premise. And then you load the data into the data marts using Polybase and Blob Store. And reporting can be both on premises or it can be in the cloud. Might want to add on Azure Data Factory onto here as well, because that can orchestrate the cloud bits, while the SSIS maintains and controls the local ones. Then you have a scenario where you are running your traditional ETL loads on premise, but you start getting sensor data, live data streaming in. And in this scenario, you might very easily set up an event hub to receive that data. You can do your stream analytics calculations in Azure, and then pipe that into a linked SQL Server on premise or an Azure SQL DB in the cloud. I've had this actually had this solution going initially at the client, where we used stream analytics into an Azure SQL DB, and then we use SSIS to pull data from there into the on-premise data warehouse. Later on, we changed that later on, but it ran for like half a year and worked pretty well. Then again, you might have Power BI as the reporting, so Power BI.com service, not the on-premise server. And you want to have live dashboarding to pipe stream analytics directly into live dashboards, and you use your traditional data warehousing for the other loads. This kind of scenario is also something I've done at the client, where we use SQL Server on premise for operational data stores, and then loaded everything into data marts in Azure SQL. That's then it's been aggregated, and we removed so personal data and so on was PII data was removed and aggregated away, and we moved everything up to data marts in SQL, Azure SQL. And then we used Azure functions to trigger Azure Analysis Services models to fetch data from the SQL DB, and then we had Power BI presentation on top of that. The reason why we moved the data marts into the cloud was that they were struggling a bit with performance locally. They had small servers, and at the same time, they had some regulations, so they couldn't move everything into the cloud. But this way, they got the flexibility performance of what they really needed to have performance in the cloud, and then they could still run things as they should locally without regulations kicking in. If you are doing your traditional data warehouse in the cloud, on premises, but you have your ERP system or your CRM system has been moved to Dynamics 365. One thing that you can look at is the combination of the common data model, which is a way of mapping Dynamics 365 table names and column names together with what you have running for the same names on your on-premises version, and then display this as a single source in your Power BI reports afterwards. They are developing this as we speak. It's still a bit hard to get the grasp of to be honest, in my personal opinion at least. But they're starting to implement data lake storage as the place to store all Dynamics 365 data that you can run data warehousing on afterwards. Together with the common data model and Power BI, this actually seems to be a very promising feature for people who are, again, looking at hybrid scenarios. So that's as far as I've got on time, since I didn't get time to show you that Polybase demo. Are there any questions come in?
If there are any questions, let's drop them in chat. There is still a good 10 minutes of session time left for questions, so plenty of time to get them in. I think one of the questions that I have, I'll ask, is around Synapse Analytics SQL pools. Where do you think they fit in? Like, what is my use case for wanting to use Synapse Analytics?
Yeah, so I have been pretty unsure of actually where to fit it in because it was very pricey, and I didn't really see the performance in it. But what I've seen lately is, for one thing, is that the price has dropped for the lowest. I think the initial one is DCX 100, and the price for that is about the same price as an S9 standard SQL DB. As long as you're doing your data warehouse, so dimension and fact table kind of setting, and you are starting to look at 1 terabyte or more of data in your EDW, I would seriously consider it. It's with the materialized views that come in now and query caching, I'm seeing performance as well as then price competitiveness with the traditional SQL way of working on data warehousing. So I would look at it that way. As long as your data is going past 1 terabyte and you have a data warehouse, pure data warehouse, SQL pools will be something to really consider.
Okay, yeah. One of the things that's always struck me as weird about them is the hard limitation on concurrent sessions. Which,
yeah,
like in a warehouse
there are
environment, I expect to have a lot of sessions. I don't know.
Yeah, they have some really weird limitations on them. I think again they're improving it for the simple reason that I think that is something that we'll also be seeing when we come to going nearer to live with the Synapse. That they're improving and removing those kinds of things because they want to compete with Snowflake, and Snowflake do not have that kind of limitation.
Right. Anders mentions mental overload. There are a lot of moving parts here.
Yeah. There are a lot of moving parts, and you will have to start again from when you're doing a cloud readiness survey. Look at the different parts you have, and start looking at these components that I've listed up to start looking. Okay, what does this do in my on-premises warehouse? Can I do it differently other places, or do I have to do it this way? There are things where you can actually have competing or overlapping functionality. So yeah, it's not as easy and straightforward as it was like 5 years ago.
Next question. I'm not sure if you've had a chance to go through this lab yet, but there was a question about whether the Synapse Analytics lab is valuable. Like, is it worth taking?
Yeah, I've done parts of it. I haven't done the full Synapse labs. I've just done the SQL data warehousing labs, and they're quite interesting. So if there are, when they come out with the rest of the workspace and the notebooks, yeah, I will have to check it and see myself, but I think that would be worth taking.
Yeah, it's been on my to-do list for literally months. I'm interested in doing it. I just haven't had a chance. A similar question. With so many possible combinations of services, it might be hard to identify the best configuration for your needs. Are there any tools to help navigate that when designing your solution?
There are some tools. One thing to look at is, things like Cloud Adoption Framework might help you a bit. Otherwise, migration tools, I can't remember what they called. So, Microsoft migration tools might help you a bit as well. Otherwise, I think it's better just to look at or to do blogs, talk to people who have been working in cloud solutions and see what how they've implemented, because there's nothing pure cut anywhere. But there are some hints and drops from Cloud Adoption Framework. These migration tools might help you a bit, and then talk to other people.
Yeah, and one other thing that I would point out, I'm actually dragging the screen over here now, is Azure reference architectures, where they have different architectures for different industries, verticals, and things that you want to hit. So at least it gives you an idea of, okay, well, if you're doing a chatbot in the enterprise space, here are the types of services that may be useful. So it gives you a starting point.
Yeah, let's see. I have Capgemini has a reference architecture that is. I'll put that in as well. I can just see if I can find one for you to show it, and I'll put that into the slide as well for you, because it's still confusing, but it at least lets you tag resources into different parts of what you need. Let's see if I find it here, and I'll just drag my screen again. So, as you can see, there are lots of moving parts here. But by looking at the different boxes, you can start at least applying different tools into those, which helps you to again draw the architecture of what should fit best where. So I'll put this in for you into the slides before Kevin gets it, to let you, to maybe, hopefully it will be a template that can be worthwhile for you to look at, and again, try all the different moving parts into the boxes and see if they fit. And of course, if anybody has any questions that are specific to their environment or specific to their needs, feel free to ping me. It's what I do for a living, so I'm happy to help.
Wonderful. Seeing if there are any other questions before we wrap up. What would be the easiest way for people afterwards to contact you?
It's either my Capgemini email or on Twitter.
All right.
As in, I suspect the Anders that was asking questions is the same Anders I know. He knows I'm pretty much always on. So.
Oh, it's definitely the same Anders. Talk Johan, great overview. Said Anders.
You're welcome.
All right, great. Well, with that, we are going to wrap up this session. The next session, starting in 10 minutes, we have Lewis Davidson, who will be talking about the fundamentals of relational database design. So you've been here for sessions already. You know the drill. I'm going to cut out for probably about 30 seconds. We'll come back online. We'll go to intermission for roughly 10 minutes, and then our next speaker will magically appear. So stay tuned, everybody. Be right back.